Now, keeping with this idea of multiplying binomials, I had mentioned that we're going to have some special cases. So two of our special cases is we have squares of binomials, and we also have the sum and difference pattern. So the first one I'm going to start with is the squares of binomials, and this one we actually have to have a little bit of a conversation because I'm going to see the biggest mistakes, okay? You guys are going to make the biggest mistakes right here. So let's talk about this. Now, 3x plus 4 squared. This is what I tend to see. Most people are going to look at this and go, okay, what do I do? What do I do? What do I do? And I'm going to see this. I'm going to see you go, okay, well, I'm going to take 3x and I'm going to square it. And then I'm going to take the 4 and I'm going to square it. And then I'm going to have 3x squared, which some of you are going to write as 3x squared. And some of you are going to go, well, no. If it's 3x squared, that really means probably 3x times 3x. So maybe this is actually 9x squared. And then 4 squared is going to be 16. And you're going to say, okay, that's 9x squared plus 16. Absolutely not. And here's why. Okay, if I give you 5 squared, what does that actually mean? Like, yeah, it's 25, but why? The why is because a squared means there's 2 of them, right? So you have to break it down and you have to say, okay, well, 5 squared is 5 times 5. That's why I get 25. So let's go back to our problem here. 3x plus 4 quantity squared. What does that actually mean? Well, it means there's 2 of them. So that means I have a 3x plus 4 times a 3x plus 4. Then I have to multiply that. Well, this goes back to multiplying binomials, which we just learned how to do. So I'm going to use the distributive property. I'm going to take my 3x, I'm going to multiply it by my 3x. 3x times 3x, 9x squared. Then I'm going to take my 3x, I'm going to multiply it by my 4. So 3x times 4 plus 12x. Then I'm going to take my 4 and multiply it by my 3x plus 12x. And then I'm going to take my 4 and multiply it by my 4 plus 16. Then I'm going to go and combine like terms, and I have a 12x and a 12x. So I'm going to drop down my 9x squared. I'm going to have my 12x and my 12x, which is 24x. And then I'm going to drop down my plus 16. And there is your actual answer. Do you notice the difference between our first answer of 9x squared plus 16 and 9x squared plus 24x plus 16? You're missing that middle term. You're missing the 24x. So distributing that exponent squared right here is a no. Because what this thing actually means is you have to write it twice. An exponent means there's 2 of them. So if there's 2 of them, then we have to distribute or FOIL, and we get that answer. Okay, so let's try that again with our 5x minus 2y squared. Again, you cannot distribute that squared. It's not going to work. The squared means you have to write it twice. So we're going to write 5x minus 2y times 5x minus 2y. Then we're going to distribute 5x times 5x, 25x squared. Then I'm going to take my 5x times my negative 2y, which is negative 10xy. I know that looks funny, but that's what it looks like. Then I'm going to take my negative 2y times my 5x, negative 10xy. And if you're thinking, could I write it as yx? Yes, it doesn't really matter. But typically when we're dealing with the variables x, y, and z, which are the most common in math, the x comes first, the y comes second, the z comes last. Just typical. And then you're going to take your negative 2y, multiply it by your negative 2y, and negative times a negative is a positive 4y squared. Like terms have the same variables, same degrees, these two, which is negative 20 xy. And then we're just going to drop down the positive 4y squared. We're going to drop down the 25x squared. And believe it or not, this guy is actually in standard form. Standard form gets a little questionable when we have two or more variables if you're dealing with x's and y's. But if you're dealing with x's and y's, this tends to be the accepted standard form. So the more you see it, the more you'll get used to it. So just kind of look at it, take it in a little bit, but that's the answer we're looking for. Okay, now that special case was squares of binomials, meaning you're taking a binomial and you're squaring it, you're raising it to the second power. It looks like that. Our second special case is called a sum and difference pattern, and this one I really want you to pay attention to because this one's going to come back later when we're factoring, and you're really going to have to identify it. So sum and difference pattern, you have x plus 2, x minus 2. So notice you have a sum, and then you have a difference. Otherwise, they look really similar. And we're going to look at what's going to happen here. So distributive, x times x, x squared. X times negative 2, negative 2x. 2 times x, positive 2x. 2 times negative 2, negative 4. Then we combine like terms. Now I'm looking at my negative 2x and my positive 2x. Well, what happens when you have a negative 2x and a positive 2x? They cancel each other. That's 0. Then you have your x squared, and you have your minus 4. Done. Okay, so look at how that turned out. In our first two examples, we have 3 terms in our answer. You have a 9x squared, a 24x, a 16. In this one, there's only 2 terms in your answer. Okay, let's try again. 3x plus y, 3x minus y. So distributing 3x times 3x, 9x squared. 3x times negative y, negative 3xy. Y times 3x, positive 3xy. Y times negative y, negative y squared. Like terms, negative 3xy, positive 3xy. Again, they're going to cancel. They're just opposites. So then we're going to bring down our 9x squared and our negative y squared, and we're done. So once again, sum and difference. We had a 3x, we had a y, we had a 3x, we had a y. One was positive, one was negative, and the middle term dropped out. Start looking at that pattern. We're going to see it more and more as we go, but that one we're really going to have to know.